Okay, so our plan today is I want to go ahead and quickly wrap up the inverse matrices, how you can use that to solve a system. Then we're going to go ahead and kind of talk a little bit about linear inequalities today and tomorrow. That'll lead us into next week when we do systems. But after that, you'll have the remainder of the period to go ahead and take your quiz, okay, over substitution and elimination. And then tomorrow when we come in, I'll pass those back. We'll talk about them, and we'll just go from there, see how things turn out. So, okay. So go ahead and turn in your inverse packet. The only thing we had left was this word problem. So it'll also be a good idea not only go ahead and practice writing another system, but it'll also give me the opportunity to remind you what we did yesterday to solve the system. Okay, so it says Nguyen is a chemist who is preparing an acid solution to be used as a cleaner for machine parts. The machine shop needs several batches of 200 milliliters of solution at a 48% concentration. Nguyen only has 60% and 40% concentration solutions, as shown here. The two solutions can be combined to make a 48% solution. How much of each solution should he use to make 200 milliliters of what we want? Okay, so I've already labeled our two variables here. So let's say A is the number of milliliters needed from the 60% solution. And let's say that B is the number of milliliters needed from the 40% solution. Okay, now one of these equations is going to be super easy. Okay, how many milliliters total do we need? 200. Okay, so I'm going to take an A number of milliliters from the first beaker here, a B number of millimeters from the second. I need 200. So what do you think that equation is going to be? That's exactly right. A plus B equals 200. Now the other one's a little trickier. You're going to have to incorporate the percents. Now normally I would like to go ahead and give you some time to go ahead and try that on your own, but I'm just going to go ahead and walk you through it. Okay, so what percentage am I looking at from that first beaker? Okay, that's 60% concentrate, right? So I'm going to go ahead and say 0.6A. Remember, if we're going to change a percent to a decimal in order for us to go ahead and use an operation, we move the decimal two places to the left. So that 0.6, that's the 60%. Okay, now I'm going to combine this with what percentage it's in the other one. That's 40%. So this is going to be 0.4B equals. Can anybody tell me what the right side of that equation should be? Okay, Tyler, what you got? Okay, 0.48. That's part of it. I want it to be 48%, so it is going to be 0.48. But remember, we're physically doing what? We're combining a certain number of milliliters from each of the two containers. So I want 48% concentration once I combine those two liquids. Is everybody okay with that? Does that make sense? Once I take the first beaker and the second beaker and I just start mixing them together, see, I'm going to have a certain total number of milliliters, but I want to do it in such a way where I end up with a 48% concentration. Is everybody okay with that? Okay. Well, now all we got to do is just, a little bit of cleanup here. So the left side of this equation is going to stay the same. So 0.6A plus 0.4B equals, okay, we'll go ahead and distribute 0.48A plus 0.48B. And now let's go ahead and combine my like terms. Let's say I want to subtract that 0.48A to the left side. So what's a 0.6 minus 0.48? Well, it's not going to be negative because 0.6 is bigger than 0.48. Imagine if it was 60 minus 48. 0.12, there we go. So 0.12A plus, now I'm going to go ahead and take 0.4B minus 0.48B. So basically, what's 40 minus 48? -8, so with the decimals, it would be minus 0.08. So instead of putting plus the negative, I'll go ahead and put the minus here. So minus 0.08b. Well, if I go ahead and move both of those terms to the left, what's left there? 0. Okay. And that is my other equation. Oh, I believe that should be a minus. Doop, 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 doop. There we go. Should be a minus. There we go. So there's the system that we need to solve in order to answer the question. Yes, sir. Actually, yes. Okay. Because you need that to be 200 milliliters. That's good. That's good. All right. So what we were talking about yesterday was creating a matrix equation. So let's take what we have here. I'm going to go ahead and create matrix A. So we call that the coefficient matrix. So look at the coefficients that I have right here. What should be my top row? Okay, so 1 and 1. My bottom row should be 0.12 and that negative 0.08. Okay, remember this is matrix A. I'm going to multiply matrix A by matrix X, which is what we call the variable matrix. Well, we're trying to solve for A and B. Okay, so A and B. And I'm going to set this equal to matrix B, which we call my constant matrix. Okay. Well, what am I going to have here? Here we go, 200 and 0. There we go. So that's the matrix equation. Very, very easy. Okay. So does anybody remember what I did with a couple of these matrices yesterday to get my answer? Put them in the calculator. What we need to do is take the matrix A, but its inverse, and multiply that by matrix B. That's what's going to give me my solution. Remember, I'm going to show you how to do this by hand, but it's going to be a while before we get there. Okay, so let's go on over here to the calculator. Where am I going to find my matrix templates? Okay, so under delete, right here on the right side next to 9, right here in the second row. So A is a 2 by 2. Okay, so let's see, I believe my top numbers were 1 and 1. Then we're going to have a, what was it, a 0.12 and a negative 0.08. Okay. Now, once I've got those entries in there, those elements, remember, I need to go ahead and use my touchpad to move the cursor outside the matrix. I want it outside that bracket. How am I going to raise this to any power I want? The caret button on the far left, right about in the middle, looks like the top of a house. Now, to show the inverse, I need to say -1. Okay. Now, I'm going to go ahead and make sure that my cursor isn't in that power anymore, times, and now I'm going to go ahead and put in matrix B. What were the dimensions of B? Okay, remember it was 2 rows by 1 column, so I have that template right here in my choices. And then I believe, what was that, 200 and then 0? Okay. Now remember, the nice thing about this is we're not going to know what the inverse of matrix A is, and right now we don't really need to. We just need to go ahead and use this to solve the system. So if I go ahead and push enter, okay, so it looks like I'm going to need 80 milliliters from the first container, and I'm going to need 120 milliliters from the second container. So if I mix that, it should end up being a 48% 200 milliliter compound. Okay. So even though this is not X and Y, you know, when I come back over here, okay, it is still AB, so we'll still go ahead and write the ordered pair, you know, in alphabetical order. So I'll go ahead and say 80, 120, because remember, that's the solution to a system. It's an ordered pair. But if you were to go ahead and just say A equals 80 and B equals 120, you're good. Okay. And we probably also should be writing a sentence, but with our time constraint, I'm not worried about that. Okay. All right, so are there any questions? Not too bad? Okay, well, good, good, good. Now remember, you got this assignment yesterday, okay, right here. This is going to be due on Monday. Monday's when we'll go ahead and take some time to look at this if you have any questions, but that gives you plenty of time. The key is already posted, just like always. All right. Well, let's go ahead and switch gears real quick. And let's go ahead and start looking at linear inequalities. Because I kind of want to go ahead and get a jump on this, not too far, but at the very least so we can kind of have an idea going into Monday how we do this with a system. So a linear inequality is similar to a linear equation, however, with an inequality symbol instead. So let's say we're given y is greater than or equal to a negative 2x plus 9. Determine which points satisfy the inequality. Okay. Well, every ordered pair is created using an x and a y. So we're just going to go ahead and say it's a solution if it makes it what? True. If it makes it correct. Absolutely. So let's see. Instead of y is greater than or equal to, I'm going to go ahead and say 4 is greater than or equal to negative 2x. So that's negative 2 times 7 plus 9. So let's see. 4 is greater than or equal to negative 14 plus 9. And what's a negative 14 plus 9? Negative 5. And 4 is greater or equal to a negative 5. Yes. So that would be a solution. Okay. We want an ordered pair that makes it true. Okay, well, let's try B. So this time, y is greater than or equal to. That's going to be 3 greater than or equal to negative 2 times negative 1, negative 2x plus 9. Okay. So let's see here. 3 is greater than or equal to. That would be 3 plus 9. Well, is 3 greater than or equal to 12? No. So that is not a solution. Okay. And because we're going to have an infinite number of solutions, we're going to be looking at these graphically. We're going to be graphing them in a XY coordinate plane. Okay. And then has anybody already been able to take a look at C, 10 negative 5? Anybody would think they tell me what it is, yes or no? Yes. So that is a correct statement. C turns out to be a solution as well. Did anybody want me to run through the substitution? All right. Good. All right. Well, let's take a look at a real world example. It says John sells T-shirts. Let me go ahead and get this out of the way. Okay. Plain shirts cost $5 and graphic shirts cost $7. And in order to match his product costs, he's got to make at least $1,200. So when you're translating this into a mathematical expression, you want to focus on the key words. This time, instead of x and y, let's use some different variables. Let's say that P stands for the number of plain shirts, and we'll go ahead and say G stands for the number of graphic shirts. Okay? And one thing about John, I got to say, I like his drip. Just close. Y'all still say that, right? You still say I like your drip? Nobody says that anymore?
Thank you.
Oh, thank you, Carlos. I appreciate it. Oh, that's no cap. Okay. All right. So write an inequality to represent this situation. Okay. All right. So how much is a plain shirt? $5. So it's going to be $5 times the number of plain shirts he sells. A graphic shirt is going to cost $7. So that would be what? Plus 7G. Now, the key here is at least $1,200. Okay. So is this referring to a greater than or a less than? Greater than. So at least this is the minimum that we can get. But here's the thing. Greater than 1,200, what am I missing? We need equality. Okay. Because if we do make 1,200 at a bare minimum, we're still good to go. Okay. That's why we're going to go ahead and include it. Okay. So B, if he sells 150 plain shirts and 60 graphic shirts, will he be able to cover the product costs? Well, let's see. I'm going to go ahead, the plain shirts, so 5 times 150 plus $7 for the 60 graphic shirts is greater than or equal to 1,200. All right, so somebody help me out here. The easy one, 7 times 60 is going to give me 420. That's a 4 right there. But I need a 5 times a 150. 750. So 750 plus greater than or equal to 1,200. Well, 750 plus 420 is 1,170. Okay. So will John be able to cover his product costs? No. No, he will not. Okay. Because that's not a true statement, so it's not a solution. Is everybody okay with that? It's not too bad, right? Okay, so this is a good lead up. Try C for tomorrow. Sometime between now and tomorrow, before we start, finish up this problem, and then we'll go ahead and run through this a little bit further tomorrow after we talk about the quiz. Okay, so that is all for today.